Hey guys, Ms. Rivera here, and today we are going to prove trigonometric identities. And to do that, we are going to recall our basic definitions. So if you recall from right triangle trigonometry, sine of theta is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. The tangent of theta, or of an angle, is equal to opposite over adjacent. Cosecant is the inverse of sine, or 1 over sine of theta. The secant is the reciprocal of cosine, which is 1 over cosine of theta, or its hypotenuse over adjacent. The cotangent is the flip of the tangent, which is adjacent over opposite, or 1 over tangent of theta. And so the Pythagorean identity is sine squared of theta plus cosine of theta squared of theta is equal to 1. And then we can use this in different variations. So sine squared of theta is equal to 1 minus cosine of theta. And then the cosine squared of theta is equal to 1 minus the sine squared of theta. And then another important identity to know is that tangent is equal to sine of theta over cosine of theta. Real quick, I want you to see why that is. But these are formulas that you are going to remember, or you can always look back at your reference sheet for. So let's look at that last one though, and then see why is tangent equal to the sine over the cosine. So to do that first, we're gonna change tangent, and we know that tangent is equal to opposite over adjacent. So instead of tangent, well, I'm gonna rewrite my formula that I see, but I'm going to change that alpha into theta, just like we have in class. And this is sine over theta and cosine over theta. And so basically today we're going to use these identities to help us simplify other equations. And so then now I can change this. So tangent is opposite over adjacent. I'm going to change that, opposite. So tangent is equal to the ratio of the opposite side over the adjacent side. And sine is equal to opposite over hypotenuse, or the ratio of the opposite side over the hypotenuse. Divide this by cosine, which is adjacent over hypotenuse. And if you recall from middle school, we cannot divide, or we do not divide fractions out like this. When we divide by a fraction, we actually can change this. We're going to multiply by the reciprocal of the second one. So this is going to say now opposite over, so our left side remains the same. We're only working with the right side, which is equal to opposite over hypotenuse. Now our denominator, we're going to flip it and change this to multiplication. All right, and now if you notice, right here we have an h and an h in the numerator, or hypotenuse in the numerator, and a hypotenuse in the denominator. Those cancel out, and so what we're left with, well, is opposite over adjacent is equal to opposite over adjacent, right? The left side is now equal to the right side. So tangent, we can change this back, tangent of theta, tangent of theta is equal to tan of theta. And I'm writing with a mouse. It is very hard, guys. Okay, so tangent of theta is equal to tangent of theta, right? And so then therefore we have proven that yes, this is in fact true. Tangent of theta is equal to sine of theta over cosine of theta. So it's an identity or a formula we can use later on. So let's look at what this lesson is asking us to do. So if we look at number 3, or number 1, it says we are going to prove the following trig identities. We're going to experiment as much as we can. And we're going to see which ones we can insert. So how can we prove that the square root of 1 minus sine squared of theta is equal to cosine of theta? And let me just double check that we have it completely. Yeah, so we have it completely good. All right. And so we're going to look up here and see, are there any identities that we might be able to use that help us prove this? Okay, and I already see some identities here, right? 1 minus cosine of a squared of theta is equal to the sine squared of theta. So would it be true that if we square rooted it, we would have, there's things we can play around with here. Can we use these things? So let's go ahead and try to prove this. So I know that 1 minus the sine squared of alpha is actually equal to cosine squared of theta. So this should be an easy one. We might be able to do this fairly simple. So can I substitute here? So I know that 1 minus sine squared of theta is equal to cosine of theta. So I can change this. I'm going to substitute in a cosine squared of alpha, right? Just like we have here, or of A, is equal to, and now we're trying to solve this, and we're going to say, hey, these two are equal to each other. And if I can get my right side equal to my left side, or my left side equal to my right side, then I know that this is a true statement. So the next thing, now we can go a number of ways. Maybe we can square both sides, and if the left side equals the right, then it's true. Or once I square root this, right, if I square root a square, it actually, right, cosine square, the square root of that is just cosine of alpha. So they are in fact equal to each other. And that is it. Once we substituted them, we were able to see that they are in fact true. Now that definitely looks like cog, but remember that's an S. It's cosine. I'm hoping that maybe I can get a stylus pen or something that will make it a little easier to write on here. But as of right now, I'm just using my mouse. So I have 1 minus sine squared of alpha, right? The square root of that is equal to cosine of alpha. We just proved that, yes, they are in fact equal to each other. The left is equal to the right. Now, we could have did it a different way and substituted it to see that cosine of alpha somehow could give us the 1 sine of squared of alpha. But in fact, we want to use the most complicated side to help us to try and simplify that side so that we can get the easier answer, okay? All right, so let's look at number 4 or number 2. It says tangent of alpha times the cotangent of alpha is equal to 1. Okay. Is there any identity or fundamental trigonometric identity that we know of that will help us? So we're dealing with cotangent and tangent. And right here, the cotangent of alpha is equal to 1 over the tangent of alpha. So we might be able to prove some things here if we substitute. All right? So again, cotangent, the cot of alpha is just equal to 1 over the tangent of alpha. This beautiful alpha right here. Okay, so now that we have this little formula, we can use it. We can actually, everywhere we see cotangent now, we can substitute that. So we are going to, in fact, substitute and plug that in. So I rewrite my next step. I have tangent of alpha times 1 over, now I'm substituting in that identity to help me get the left side equal to the right. Well, tangent of alpha times 1 divided by tangent of alpha. Can we make it equal to 1? Well, this just becomes tangent of alpha, or A, over tangent of alpha. And we know anything over itself, right? Tan of A divided by tan of A, that's the same as 1. 1 is equal to 1. So in fact, we were able to prove that tangent of alpha times the cotangent of alpha is equal to 1 by substituting using our trigonometric identities. And so as you continue to go on into the questions, you are going to try and find the identity that helps you helps you prove that the left side is in fact equal to the right side. And so with those two examples, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8. Maybe 8 more left. All right, and if you need any more help with this, you let me know. I can make another video if you need it, and then I will have my office hours. So don't forget that when you go online during our class time, you definitely want to check and see if it is an office hours day. I'll be on Teams, able to answer any questions if you have them and guide you through this lesson. Right? Definitely look at the videos in our class pages, the other videos from YouTube. Take some notes, and hopefully they help. Let me know if you need anything. Stay safe.